All right, so hello everyone. I am Dan Strutman,
Lindsay Reddington.
And I'm Sanjay Smanandar.
and we are going to be going over our project 2 over sorting data and encryption algorithms in C programming. So I'll start with a little bit of an introduction. All right, there we go. So I'll go over the purpose first. So the purpose of this project was to create 2 C programs in our Linux environments. One of these was a selection sort algorithm, and one was for data encryption. And in order to program these algorithms, we had to use our VI text editor and create 2 separate programs to complete these 2 tasks. So upon the completion of the selection sort algorithm, we had to relist the numbers from the original num.txt file into ascending order. And for the second algorithm, we were responsible for encrypting a message and outputting the results onto a new text file. After this, we had to write a decryption algorithm that did the exact opposite. So whereas with encryption, you are encrypting, you are securing the data. Decryption is all about, reversing that to the plain text, which is what decryption is. And this project, the importance of it was highlighted as each of us, are going into a career revolving around technology. And the world of technology is constantly evolving. We're always having to find, new ways to update ourselves and the information that we have to learn. And just as methods of breaching information are becoming stronger, hackers are becoming more knowledgeable. People more and more information is going to circulate the internet, and we have to learn how to find ways to secure that via means of data encryption. And as well as this organization with this vast amount of data is so important, which is why selection sort and organizational algorithms are so important, because we can use these algorithms to organize the data in a way that's more readable for everyone else that needs to have access to this data. And because of this project, we as a group were able to aid ourselves in the process of gaining technical experience that will prove invaluable to our future job endeavors. And as a result of this project, we all have experience that will be beneficial for each of us in the coming years regarding data security and information organization.
Okay, so the first task that we were assigned to do was selection sort algorithm. So let's go through it first. The selection sort algorithm is an algorithm that sorts an array by repeatedly finding the minimum element in any order or stated required, mostly ascending order, from unsorted part and putting it in the beginning, or finding the maximum from the array and putting it at the last of the sorted array. So for this project, we were supposed to initialize, and so we were supposed to read from a file which was given as num.txt and sort its given content in ascending order, and then write the sorted content in another given file as ascend_num.txt. So at first, for this algorithm, first we find the numbers of integers in the file, which was num.txt. Then we read file into the array, then sort array into ascending order, and write the sorted array into the new file, ascend num.txt. So going on, we use file size, that function which that opens the given file and counts each integer in the given file and returns a total count to the main function of the program. Then we call the read file, the array read file, which opens from the given file, the num.txt. It opens the given file, then saves each integer from file into the array which we are using to sort to send the selection sort algorithm in the file. So after that, we implement the selection sort algorithm, where we find the maximum in the array and swap it to the end of the array and repeat it for each indexes. After reading the contents from num.txt and sorting it in ascending order, we find the maximum on the array and we put it at the end of an array. That process keeps on going on a loop until all the contents from the array is finished. After that, we use the function write to file, where we open the given file and print each index of array into the file to the new file, which now is sorted using the section sort algorithm and placed in ascending order as required by the project. Then after it's placed in after the array is placed in its file, we close the file and we move on with our coding.
Now it's time for the demonstration of the selection sort algorithm. So this is the, after I SSH into my virtual machine. So we know that we use num.text. So if I open that up for you guys, you can see what numbers we are sorting. And then if you want, we are putting that into ascended num.text. And you can see that this has not been created. So there's no file, which means that there's no like preset numbers that are already in this file. Once we call it, which I've saved as sort, you can see that it was done correctly because nothing pops up. And then once you open up ascended num.text, you can see that it is in ascending order, and it has 2 decimal places as well. You can see it goes from a far negative to a very large positive number. Now that that is done, we can move back to the rest of the presentation. So the next step was, or the second part and second code was for encryption and decryption algorithm. For this, we needed to find the length of the string in the file. We needed to read the string into an array, encrypt the string, and output the encrypted string to file. This is the encryption part. So we're using our function file size to find the number in order to create an array big enough for the file. Then now that we have that file created, or that array created, we can then open that file back up and read that string into the array, bring it back to the main function, where we can then encrypt it with a couple different functions that I will later say. And then you output that encrypted string into a new file, which we called encrypted message.txt. Next, you read the string from the encrypted file back into another array. I just wrote over the array, so you'll see the callec function was used to clear all of those arrays so that they could be prepped and empty for the decryption process. So now that those are empty, we were able to use the read file function to fill our text array up with the encrypted message. And then we used the letter to num, multiply, and num to letter functions in order to decrypt it. Then we output the decrypted string into a new file, which in this project, it is result message. So first, with our first step of file size, this is the function that we used. You can see that we start with size equals 0. We have to initialize it so that we can add 1 each time the fgetC function finds a new character. And then we continue this loop until there's a new line character, because that signals the end of the file. That's how I created it. That's how I wrote it. But it first has, if it isn't able to open, the program will print error opening file, and then it'll end that function. And once the size and once it's gone through the entire file, then it'll return the number of characters that it found. And then that brings you back to the main function so that you are able to create that array. Then once you have your array created, you'll want to read the file into the array or the string that you have in your main function. It's similar to the size, except instead of adding 1 to count each time, you are putting that character that you found into the string using a pointer. But in order for simplification for decryption and encryption, because later you'll have to change the letters to numbers, I simplified it by changing all of the letters to lowercase. That way they're all the same and it simplifies the program. And then once that's completed, you close your program or you close the file. Now that you have your string of like plain text, now you can encrypt it. So this is first done. We use a block cipher for this project. So that is a mathematical function where you're multiplying, in this case, a 2x2 matrix with a vector of 2 plain text. And in order to do multiplication, you have to change the letters into numbers. For this project, 1 is A, B is 2, C is 3, and so on and then Y is 25. And then when it wraps back around and Z equals 0. So for our letter to num function, we created a string that has each letter at its corresponding index value. So like A is at index 1, B is at index 2, and so on. And that helped to assign and go through as we did a loop throughout the entire index. We tested the character at each index of the string and compared it and tried to find that same corresponding letter in our letter array. When we found the same letter, the index that letter was at is then saved in place of the original letter in the message. So then you're returned with, you end with a array that's full of numbers. So say if you had a string that said ABC, it would return 1, 2, 3. And then once you have numbers, you can then perform the multiplication. Right now we're doing encryption, so we want to use the encryption key. And for this function, I made it to where you can say which key that you want to use. That way you can use it for encryption and decryption. I created a pointer for each part of the matrix for the key. And then I did a for loop where it took blocks of 2. So it went every 2 indexes. And I returned it in a new empty int array where it did the block cipher equation. And I did it mod 26, that way that we didn't have to do that later, just simplified and shortened the instruction. And you can see at the end of the for loop, it's p plus equals 2. That's shifting the pointer for the array 2 spaces. That way it is still correlating with how I is shifted. And then now that you have these new numbers, you can then convert those numbers back into letters. This is done the same way, kind of in a reverse. It's similar to what we do for letter to num, but instead of finding the character and then saving the index, you are finding the you're given the index and you have to find what character is at that index and save that character. And so you do that throughout the entire int array, your encrypted number string. And once you have that done, you then have your ciphertext. So now that you have your ciphertext, you can then write it to a file. After it's your encrypted message, we used encrypted message.txt, and then we use the fprintf function to print each character into the file. And it's just character by character. There's no spaces, no commas, just to simplify things. If there is an error opening up, it will print out the error and quote and the function just like before. And then now that we have our encryption done and we have a file that contains the encrypted message, we want to decrypt it. So we do that by reading that encrypted message file, which I already explained the read file function, so I won't go too far in depth with that either. It's similar to before where you save each character from the file into an array. You don't have to find the file size because you already did that at the beginning of the function, and your the original file size won't change from before. Now it's time to decrypt the string because now you have the encrypted message into a string. This is done by converting the letters into numbers using that letter to num function that I mentioned before. Then you're performing that multiplication in blocks of 2 with your decryption key. So it's really important to use the decryption instead of encryption, or else you'll just be encrypting it again and you won't get your plain text back. And that is done by the multiply function. And then now that you have these decrypted message numbers, you then want to convert those numbers back into letters. We use the num to letter function. Now that we have the decrypted message in characters or letters, we can then write that message into a new file, which in this project it is result message.txt. This is similar to what was done before, where you print each character from the string into the file, and then you close the file. And then now it's time for encryption and decryption, the demonstration. So pull that up here. All right. So we can see the files we use. I'll start from the beginning. So you have message.txt, and you can see that it contains the plain text that we were given for this project. Then our next one is encrypted message.txt. You can see that that one, it's empty, there's no file. And then the last one is result message.txt. You can see that that one is also the same. And I saved it as encrypt decrypt. So this is the function for encryption and decryption. And now that we run that, we can then open back up we'll open back up message just as a reference. And then you can open cat result or cat encrypted message.txt that opens up the encrypted message file. And you can see that it's all lowercase. Like I said before, when you read the file, I switched it all to lowercase. And it's also the same length as the original, the message.txt, which tells you that the length of the plain text was even because you do blocks of 2. So if the size is odd, the program adds 1 to the side before it creates the arrays, and it also adds a filler. So you can see that there is no filler because they are the same. You can also tell that it's just a bunch of random letters. So hopefully the program didn't work properly. The real way to test is by doing your result message.txt. And so once we open that up, you can see that it is exactly how message.txt is, except it's just all lowercase instead of some upper cases. So that can show you that our program did run successfully. And now that we have demonstrated, move back to the presentation.
All righty, so I'm going to sort of wrap things up for us here today. So the point of this video was to highlight our recent experience regarding our programming of the algorithms, the selection sort, and the encryption decryption algorithm. Over this video, we've explained the steps that we had to take in this the process, the programs that we've written. We've broken down our functions, and we provided you guys with resources such as our screenshots, demonstrations, and this video right here to hopefully help you guys, follow us along on our journey with these programs. Our report was written with the intention of summarizing and explaining our project and the process of navigating Ubuntu Linux and different coding environments such as the VI editor that we had to use. And the knowledge of like VI editors, virtual machines such as Ubuntu are very important because we as technological, hopefully future employees are going to have to be able to adapt and work in many different environments such as Ubuntu or a different virtual machine. But the point is, we're going to have to navigate that and be able to write programs that will allow us to complete a goal. This project really allowed us to gain, knowledge in an atmosphere that allowed us to collaborate with one another and work as a group. That's also very important because in future jobs, almost any job, you're gonna have to work with other people, find out how to put your minds together to really come up with one solid project. So I just want to, re-hit on the importance one last time of what we've done here today. So the selection sort, with how much data is circulating the internet nowadays, it's very important to have, a method of organizing this data that would make it easy to read for, colleagues, your boss, your employer. Just being able to access this data in a much more legible way is crucial, because with all this data, organization is key. And the importance of data encryption and decryption with, the measures that hackers are taking to access information now is crazy, through like Wireshark, just breaching data in any possible way. The importance of encrypting this and securing the data is crucial, because like information, so like, credit card information, bank information, medical records, anything important can leak out on the internet. And that is why it is important to have means of encryption. And websites nowadays, Google has, it's not necessarily required, but they are strongly encouraging that all data is encrypted on websites to make sure they're secure. That's whenever you see that, like the lock up on your URL tab up top on the top left, that means the data is encrypted, it's secure. There's no end all be all, oh, this data is 100% secure, not safe and secure, but encrypting the data is the best way to do so. And decryption is important because we need to be able to translate information into, using a key that is like readable for us as individuals. And I just want to wrap things up with a big thank you to you guys for listening to this video, for joining us here today. And if you guys have any questions, feel free to reach out to either me, Lindsay, or Sanjesh at any point. All right, thanks guys.